All right, here is the first problem from the chapter 16, 17, 18 review packet. The function f is defined between -4 and 3. The graph of f is given below, so notice it stops at -4 and it's stopping at 3. The graph has a local maximum when x equals 0. Okay, so they're telling us this is a local maximum, and a local minimum at x equals -3, and when x equals 2. Draw the first derivative and the second derivative on the graph. So remember, the first derivative tells us the slope. It is the gradient function or the slope function of our position function. So I know the slope right here is 0, so I'm going to have a slope of 0 at -3. So my y value is what my slope is. So y is equal to 0 right here. So when x is -3, y is 0, because my slope right here is 0. So the same thing's going to happen right here and right here, because remember, the gradient function helps us find where the slope is. It helps us find the maximum and minimums of the original function, because at the maximum and minimums, the slope is 0. All right, so now I need to figure out, well, what does it look like in between these? So to the left of -3, notice I have a negative slope. So I'm going to make a little sign diagram first. I'm going to have a negative slope. And then between -3 and 0, I have a positive slope. And then between 0 and 2, I have a negative slope. So that means my y values are going to be negative on my first derivative to the left of -3, but then they're going to be positive, and then they have to come back down to the 0, and then my y values are going to be negative after that. So I'm going to have a parabola, upside down parabola, right there. But then, lo and behold, I forgot to do this side. To the right of 2, my slope is positive again, so I need to come back to 0 and then continue up. Okay, so that looks pretty ugly. Maybe I could do that a little better. That looks nicer. Okay, so that would be, and I guess I'm going to stop at -4, and I'm actually going to stop at 3. All right, so that is my f prime of x. Now we're going to find the second derivative. So I'm going to do the same thing again, focusing on my first derivative. So I'm going to go ahead and get rid of these plus and minus signs. Okay, and let's see, do I have a colored pen around? Let's go ahead and mark this. So now I'm going to look at this one. This is my first derivative. I'm going to look at my first derivative, and I'm going to do the same thing. I'm going to figure out where are its maximum and minimums. So it looks like it's probably a maximum right here in between -2 and -1. And we got a minimum down here. It looks like that's maybe at around 1. And then I'm going to look at my slopes. I have a positive slope to the left of here. So I'm going to have positive values, positive y values. Then it's negative slope from here down to here, so I'm going to have negative values. And then from here to the right, I have positive values. So I need positive y values. Then I'm going to need, from here to here, I'm going to have negative y values, and then back to positive. So positive, negative, positive. Whoops, I keep putting arrows on the end of that, but really I should just be going to 3 and stopping. This one, well, I'm kind of running off the graph, so we won't worry about going any further that way. All right, so that is our second derivative. Okay, that was A. Write down the x-intercepts of the graph of the derivative function. Okay, we know for sure what the x-intercepts are of the derivative function because they match up with the maximum and minimums of the original function. So those would be -3, 0, and 2. -3, 0, and 2. That's x equals. Write down all values of x for which the first derivative is positive. So my first derivative is this purple line here. It's positive where y values are positive. That's what they're talking about. So when x is greater than -3 and less than 0, that is where it's positive. Okay, at point D on the graph of f, the x-coordinate is -0.5. So at -0.5, there is going to be a point on the graph that's going to be called D. So on the original graph, there's going to be a point D. And explain why the first derivative, oh, actually, does that say second derivative? I don't have my glasses on. Oh, I think it says second derivative. Explain why the second derivative is less than 0 there. Okay, so the second derivative tells us about concavity, and so notice where D is. It is on a stretch of the original graph where it's concave down. Okay, so the graph is concave down. The graph f of x is concave down at x equals negative 0.5. Therefore, the second derivative is negative. Okay, and we can see from our sketch also the second derivative is the y values are negative. And that makes sense because the original function is concave down in that area. All right, that was problem 1.